camshaft position signal, red, and this is gonna be the green color for the current for different waveforms. Okay, let's go and analyze that one on the screen. Let me pause that one. We have here one event of the cam, V60. Welcome everybody to your automotive channel, Hoyle Automotive in Action. We're gonna be doing some diagnostic today here on a Honda Odyssey 2007, which the customers comment, check engine lights on, goes on and off sometimes. Now it's off, you see, it's good. Start the vehicle and the light goes off. Okay, so we're gonna go through the process of doing first a code scan on the vehicle. Well, I'm gonna be focused right now only on the engine computer. Leave the key on and go there. Okay, now we can see we have here two diagnostic trouble codes. P0137, heater O2 sensors, sensor 2, circuit low voltage. Okay, what does it mean, low voltage? So that means it's gonna be near to the 0 volt. So when you say high voltage, it's gonna be near to the 5 or 7, 11, whatever they have the highest voltage. They have a manufacturer code here, P2270, heater O2 sensor circuit stock signal stock lean. Okay, so probably it's not, they don't see any fluctuations on that one. So what we're gonna do is get some data related to the heater O2 sensor. I would like to get the air filtration sensor both, because this code could be caused by one of those two. So we're gonna get the two air filtration sensor in milliamps. We're gonna get the RPM to let them know others what are the RPMs of the engine, and also I will get the APP sensor to let you know how much I'm accelerating or what I'm doing here. Go to the next step. We have here the data related to O2 sensors. On top we have an air filtration sensor for bank 1 and bank 2, 0 milliamps. So that one is zero compensation, perfect, like air filtration lambda. And we have APP sensor. I will accelerate right now. Look, see, accelerator, engine speed, so that will let you know how we're doing. And initially with the vehicle call on the bank 2 sensor 2, I was getting about 1.4 volts on the bias voltage. So that seems like the sensor is pulling that down, and now it's getting temperature. If you see, that one is going up a little bit, 9.2, 0.92, and but the one on the top, band 1 sensor 2, the bias voltage is way lower, 0.43, while the other one is 0.96. It's just going up a little bit. So we're gonna find out if that voltage is being, well, there's two ways how we can know that one. One is unplugging the sensors and finding out if the bias voltage returns. That's one. The second is we can inject some voltage throughout those connectors and figure out if the wiring integrity is good. First, we gotta know bias voltage. Second, we can inject voltage. And third, well, we can check on the scanner and see if the scanner reacts about that. So, but for now, we're gonna drive the vehicle, and I want to do a wide open throttle on the highway and figure out the changes on this. Let's do that. I'm driving as kind of steady cruise. I release the throttle now, and I'm just gonna start driving on the highway I will do kind of wide open throttle, so that way we can force the system reach, and all the sensors should reach. And on deceleration, all sensors should read lean. So let's do that now. I'm just about to get here into a let's see, I'm just gonna get here into do a wide open throttle now. Let me see all the light. Hope you guys can see it. Did a wide open throttle there. The release. So do it again. So apparently that sensor is stuck. It's not moving. As you can see, that sensor is not moving. Do it again. Look, I'm just holding this the phone against the cup holder here. Look, right here. And I don't want to be taking my eyes too much on the screen. You know, I wanted to have it on the road because I'm driving. Let me do a wide open throttle. If I get off from the screen there, so apologize, because I gotta keep my eyes on the road. Acceleration. Okay, so that sensor is not producing the signal, so it's stuck there at the system set. Okay, so next step is we're gonna be doing some wiring integrity testing. Let's do that. Well, here it is, the bias voltage. Now it came back. So the bias voltage was stuck before, so now it went back to 1 point. Well, same thing. Both sensors are the same now, the bias voltage right here. So probably the sensor is the one is pulling down this, but still we're gonna do some testing. Let's have the key on right now and the vehicle is not running. I'm going to take a look here at the bias voltage now. Look at here. So we have here the two downstream O2 sensors, and the bias voltage is at 1.275 on both. So that's telling me the wiring integrity from here to the computer is fine. The computer is the source of that voltage, so that's good. And those are just the current for the air pressure sensor, which should do nothing now, so it should be fine. So right now what we're gonna do is I'm gonna inject voltage on the bank 1 sensor 2 to check the integrity of the wire. At this point, this one should be enough, but I wanted to find out if the computer is capable of processing that voltage with the simulator. Let's do that. So I have here the simulator. Can you focus? Well, I have here the simulator, and what's gonna happen is I'm gonna connect that one on the back of the O2 sensor signal wire back there. If we can see it, hard to see it. It's hard to see it, but it's back there, way on the back here. Well, here maybe. Well, is there? It's connected to the O2 sensor signal wire, and we have it here. So now let me plug it here on the sensor simulator, and I'm simulating a zirconia sensor. So let's check inside what's going on here. So yep, we can see here the computer is processing that data. Look, do you want to see that one graph? So we still see that one, the voltage here, like bias voltage on that one, and on this one we can see the fluctuation there. So I'm simulating a zirconium O2 sensor there with a sensor simulator tool. So that's telling me, see, the computer is detecting 1.2 voltage bias voltage, and the rest is the sensor we're injecting. See, about 200 millivolts to 800 millivolts. Okay, so that's it. We're gonna put a sensor now on it. Should do it.